Actually, I'll do the minimization so we can. Oh, never mind.
You can't?
Yeah.
How? Why not?
Well, this is like inception.
Set it on the laptop as long as you turn it over, I think.
Alright, should we get started?
Alright. Sounds good. Yeah, everyone just try to take the time to fill out the attendance form. Link is on the slides up there. Also make sure to enter in the number of the day, which is 2110.
Alright, can everybody hear me? Good? Yeah. Sorry? Did you ask a question?
Are you using your Cornell email?
Alright, so is everybody good with the attendance form? Anybody need a minute? Okay, sure. No problem. Okay, what's it looking like now? Thumbs up? Everybody good? Cool. Oh, one more? Okay, you're good. Okay. Alright, so yeah, if you didn't fill out the attendance form, it's okay, just come back to us at the end of the lecture. I'll give you the link. Alright, so today we're going to be talking about a little bit more on views. Like I told you, a lot of the topics that we cover in lecture 1, we're going to be covering again so that it's not like a one and done sort of situation. The idea here is to give many exposures so that you're comfortable with the material. So homework 1 was due yesterday. If you didn't turn it in, you have 2 slip days that you could use on homework 1. But otherwise, definitely get that going. If you need any help, please come to us. I know there's been a little bit of mishaps with the places of office hours. So if there's ever any issues with that, just contact us. We'll do an impromptu one-on-one with you and over Zoom or whatever. Just whatever is convenient for us or you guys. So Student Center or CMS, if you're not on either of those, let us know. We'll help and make sure you're enrolled and all of that. It should be 2 credits SU. If you did not attend lecture 1 and are not attending lecture 2, then you will be dropped from the course. So make sure that you're keeping up to date with the attendance forms and everything. And homework 2 will be released after class, and as always, we'll stay after for like an hour or so to help people get started if they'd like. And the lecture topic today is pretty topical for getting started on homework 2. And homework 3 will be an extension from homework 2. So you'll be building off of what you do in homework 2. But if you do have some questions on it, it's better to answer them now rather than later. And if you need to contact us, rather than emailing, so we have like a billion channels of communication. So we're going to try to standardize and say, just make a private post on CampusWire, and that's probably the best way to reach us. Yeah. And now a little bit of talk about our new feedback form policy. So last we checked yesterday, none of you guys filled out the feedback form, and this is required. So I mean, I guess your lack of filling out the feedback form is in itself a form of feedback. So we'll change the policy if it's. The idea is it's supposed to be like 3 points, and it's a way for you guys to tell us like how you feel about lecture. Is it going too fast? So we can adjust accordingly. But since it seems like too much to keep up with, we changed it to be less frequent. Now it's going to be midterm feedback and final course feedback. And so that's going to be worth 3 points each rather than 1 point for each point. And if at any point you want to like let us know like, hey, like your lecture stuff, just make a private CampusWire club So office hours, just a couple of updates for this week. We're working on getting better rooms. 25 Live, the booking service this semester really sucks, and it's really hard to find like decent locations this late in the semester. And the person who's supposed to help us is on ghosting. So yeah, we apologize for the bad rooms, but we're working on it. Hopefully the rooms will get better. But for now, there's always the Zoom option if you prefer. Even if it is an in-person one, just contact on Campus Fire and say, hey, can I zoom in? And the answer is always yes. Also, watch the locations on the website before you go because they're subject to change. Hopefully we're going to get better rooms. And Hai Chen, his office hours are usually Monday at 1. But this week only, he's rescheduling it to be Wednesday at 1 on Zoom. But it'll go back to normal in future weeks. And office hours are available by appointment also if none of the times are working for you. So just contact me or Shirley and we'll create an appointment for you. All right. And also we have coffee chats. This is a course tradition going back like 4 semesters now. So if at any point you want to learn more about the team or talk to anybody on the course staff just about anything, we make that option available. There's a little section on the website to do that. Okay. So we're going to review some topics from last week, lecture 1, make sure that we're solid on it. So Kotlin is a language with nullability. So the idea here is to think about it's sort of a syntax, a piece of syntax that's unique to Kotlin. So if we have this example here, we have val name of type string, where we are explicitly defining that this value name is of type string equals null. And we see that this is incorrect. This is incorrect for the reason that we do not have the question mark. The question mark is sort of a null safety measure that Kotlin has built into its language. So when we're dealing with values that, especially this val, which will be null forever most likely, since it's not a var, and the whole topic of mutability, we have to put this question mark for null safety. And here's the thing though, this isn't like, once again, something I memorized. Android Studio is very nice, very forgiving. It'll tell you if something's wrong, hey, you forgot a question mark, and just accept the recommendations it gives. But the idea is, why is it giving me this thing? Why is it telling me to do this? And this is why. Okay, mutability. So you all did homework 1, hopefully. Who can tell me why? Well, what's the deal with mutability in Kotlin? All answers are good answers. Yeah. Yeah, totally. So var for being able to change things, and val typically for values that do not change throughout the course of the program. Very good. And just a little review on the different views that we have. For our layout elements, we do them in XML. XML is how we create our elements and layouts. And who can tell me where XML stuff is located? Where in my file structure will I be able to find XML files? Yeah, the resources folder. Yeah, absolutely. So the res folder, if you're looking through. So good. Anytime I'm looking for an XML file, odds are it's probably in the res folder. We have an edit text, for example, which is this top number 1 right here. This is where I can type in different text, search bars, for example, or maybe a user login, things like this. This is an example of an edit text view. A button is exactly what you think it is. It's an element that is clickable, and then some action will happen after I click it, or I guess it could do nothing if you wanted it to. You can have a text view, which is just a way of displaying text on your layout. And you can also have an image view, which is our way of displaying images on the app. Any questions about this? All right. So the res folder, which we were talking about before, this is where we'll find a lot of our XML assets, right? So drawable is one of them. It contains images and icons, fonts, if we have any custom fonts. Layouts is like what we were talking about, where we put our views, like edit text views, things like that. Raw for audio and video. Midmap is also containing icon images. And super important are some values we do not want to hard code, like colors or certain strings, or styles or dimensions, like 300 by 200. So colors, for example, I don't want to have to memorize cornflower blue every time. So we put cornflower blue into colors.xml, and then I can reference it in the code where I want to actually use cornflower blue as like the background of some view, for example, the background color. Okay, any questions about this? Excellent. Okay, let's move on. Okay, so and now parts of an activity. So the layout files, the XML, which we said are located in the res folder under layout, the layout folder under the res folder. And the program files, which is where the logic is, the Java Kotlin files, are typically in java/com.example.appname or whatever you make your package name. One thing to note, in Android Studio, if you change the view, so at the top, it could say Android, it could say project files, it could say many different things. A lot of times when people don't know where they are in the file structure, it's because they've changed the view. Android Studio will automatically like eliminate some folders and hierarchy of the file structure for you if you have it on different views. So under the File tab at the top, you should see Android or project files, whichever you prefer. I typically go with Android, and it's the more sensible thing to use for Android developers. Okay. And this is the code behind it. So the use of a resource file, I just want to emphasize this again. I shouldn't be seeing hard-coded strings. We should hopefully be seeing uses of @string / whatever the name of the string, like dining hall name or something like that, or user or something like that. Okay. And also to review our input controls. So edit view, we talked about the edit view before for inputting text. Seek bar, this is going to be very important for the new homework, which is used to represent a range of inputs, so like from 0 to 100%. Checkbox, which is self-explanatory, number 3. Radio group is sort of like multiple choice, and number 5, the switch is like for switching on different things, and number 6 is a spinner of multiple options. Okay. And some more topics in file structure. The Android manifest is where we put a lot of our information about system level things going on, like the permissions that we're going to be using for an app. And the build.gradle is a file where you set basic configurations. This is where we put like Play Store information, things like that. These two files have like a lot of administrative information, like third-party libraries you may be using, stuff like that. So this should all hopefully be reviewed from lecture 1. Any questions? Okay, cool. And let's move it. Okay, so we're going to talk a little bit about file structure. So we have a hierarchical tree when we're dealing with XMLs. And we're going to use attribute tags like Android :ID. This should hopefully be a little bit familiar now that we've seen what an Android project looks like. So for example, under this frame layout, we have Android :layout height and Android :layout width. So this is us saying the height and width of this frame layout is going to match its parent. So whatever the size of the parent is whatever we're going to set its height and width to. So this is a very specific type of syntax that we use in a lot of our XML files that you'll find is different than the syntax that we use in the Kotlin file. So if I wanted to change something in the Kotlin file about this, let's say I'm in my Kotlin file, and I now want to change the width of this frame layout programmatically. What I would do is I would access the attribute of layout width from the frame layout and set it equal to something else. So this is something I do. Find view by ID. So in this example, we're specifically talking about the text view. So do you see how in my text view I have Android ID equals @ID text view? So what this means is, let's say I had 3 different text views and I want to be able to identify which one is which. I give give them an ID. So that way, when I'm in my actual Kotlin file, I can grab it by its unique ID that I set, and then change stuff in the Kotlin file about that text view. First of all, does this concept make sense? Are we sort of understanding the process that's going on here? Good. Okay, so this big R means I'm coming from the resources. So coming from res, look within the IDs, and there is an ID called text view. This ID text view matches the same ID I set on line 8 here. And so this will give me the view. This display variable has view in it, specifically the text view in question. And so I can access things about this text view like it's text. So I could programmatically say like display.text equals and then something else rather than hello world. So that's how I can change things to my XML from the Kotlin file. Okay. And now activities. So activities can typically be thought of as screens. So main activity is my main screen. I could have like a screen for the login page. So I could have a login activity. I could also have an activity represent some other screen that other logic happens on. This is typically how we divide it. Different screens, quote unquote, are broken into activities. So they can take up only a segment of the screen. They don't have to be the entirety of the screen. Typically, they're thought of as like the container of things like fragments, and we'll learn about fragments later on. So, yeah, and we'll learn about that in lecture 5. Or the screen could theoretically be just XML. We don't actually have to add any logic to it. It could just be a static sort of image, and in which case, not much of a reactive application, but it's possible. Okay, so before we move on, any questions about activities? And I just want to emphasize any questions are good questions. Okay, move on. So here's an example of a main activity versus a campus eatery activity. So on the left, we have the main activity. This is the main screen of the eatery app when you open it. At least it was sort of a vintage screenshot. But this is like what you see when you open it. This is the main activity. There's many different cards here that you could click on, and you could scroll through multiple cards. And then if I click on one of those, I'm greeted with the actual information about the eatery, right? I have this bare necessities on the right, and this would count as my campus eatery activity. So we've launched a new activity that represents a single campus eatery. Does this make sense? Okay, now we're gonna, without going too much into it, this is actually a fragment that's being hosted within an activity. So this is a sort of unique way of creating applications. We'll learn more about what a fragment is and when you can use fragments, but just know that the activity may not be the entirety of the screen right now. But up until, I think, lecture 4 or something, we're going to just be dealing with it. Okay, so now we're going to talk about how do we read documentation for Android, because I find that a lot of the questions that we get typically deal with people who maybe didn't have a lot of background in reading like enterprise documentation, and a lot of the answers typically lie within the Android devs documentation, and I'm not going to lie, that shit is confusing. So let's go ahead and let's take a look at a deep dive in the color module. So let's say we were interested in dealing with different color spaces, homework 2, and we wanted to sort of be able to convert between different color spaces, like RGB and HSV and things like that. So in this case, I come across some function called HSV to color. One of the most important things I should be looking at here are what are its arguments, what do they represent, and what does it return? Its arguments are a float array of exactly three values. I have the first one representing its hue, the second its saturation, the third its value. And we have different bounds on what each of them should be. 0 to 360 for the hue, 0 to 1 for saturation, and 0 to 1 for value. So this is not at all intuitive. If you've ever learned HSV, maybe you thought of it as percentage, 0 to 100%, or same goes for saturation, 0 to 100% saturation. But you're seeing the representation invariant here is actually that it's 0 to 1. Okay? And so if the values are out of range, they are pinned. And the parameters, we have a 3-element array which holds the input of the HSV component, and it returns to us an integer, the resulting Rgb color. So let's sort of think about what this return value represents. It says it's returning to us an integer, but it's not really returning to us an integer in the sense of 35 or 82, because what would that really mean? If I gave it a color at 36000, that represents some color. What is that? Black, white. Regardless, it represents some color, right? And its integer value is not inherently meaningful. But it becomes meaningful when I understand that they're using integer to represent color. So there is something that you'll find if you continue going through the documentation where they talk about color as just an integer. So Android has their own way of representing colors called an Rgb int. And so if I want to go from some HSV value to an Rgb int, I would use this function, HSV to color. So, and the other thing to take notice of is the fact that what it says that it does. So it converts it to an Rgb color, and then also set to 0 or +85 or whatever. So, okay, does this make sense? What we're doing here is we're sort of understanding what it is that they're saying. And so the key is to take note of the return is not as intuitive as you think about it. It's not, so I could be tempted, right? I see int, it returns to us an integer. Well, color is sort of an integer of its own class. They just use integer as its data value. Does that make sense? This was just a closer up. So here is an example call that I could use the HSV to color on. So take notice of the fact that I'm using capital C color before I make the call, because this lies within the color package that's available to us when we are using Android Studio. So you would have to import it, but if you just type this in, the IntelliJ's Android Studio is pretty intelligent, and it will auto import it for you or prompt you if it's like a large import. So what we're doing here is we're passing in ARR. ARR is an example of an array. So how many values should this array have? 3. Okay. And what's its data type for each value? Here are multiple. Someone raise their hand? Yeah. Float. Yeah. So it should be a float. And now what does it return to us? What will be my result for val color? An integer representing a color, an Rgb color, however Android represents that. Good. And I can use this value directly with Android because Android likes Android versions of color. Okay, cool. And so we can see if I wanted to pull it from a seek bar, for example, this is something that I could do. I could pull the progress of a seek bar. So wherever I drag the seek bar, I can pull its progress, and then I could then pass it in as the array value, something like this. And initializing the float array of size 3, since when we create arrays, we have to tell most languages how big the array is to allocate the right size of memory. Okay, keep moving. So Rgb is another function that we're going to take a quick look at. So it takes in 3 arguments, red, green, and blue. They should be floats. This should hopefully be somewhat familiar now. And this notion of returning an int, because it says return a color int. So we know now what a color int is. We know that this is giving us back color how Android likes it represented. And so we have floats for each of the parameters, and this is very similar to the one that we just looked at. Okay. So this is what a function call for RGB would look like, and we give it 3 parameters. Okay. And then now if I wanted to do the converse, I have a color int, and I want HSV values. So if I wanted to do something like this, I would have to pass in my color int that I had gotten somewhere along the way. And then I would convert this Rgb color to its HSV components. And take note of the fact that I have to pass in a 3-element array. And this 3-element array will have float values for each and will host our result. So whatever our result is, we can access it from the array we passed in. So this may seem like a sort of strange way to get a result, but this is simply just how Android has defined it in their color package. Okay, and that's it. Any questions about what we covered in lecture today? Yeah. Yeah. Oh, you talk about it? You want me to say it? Sure. We'll see more about this in demo, but basically, so seek bar hue. This is some, because it's a well-named variable, you should hopefully think if there is some seek bar that represents hue, then this would be the seek bar of that same title. And basically, we want to get its progress. So if I had dragged it all the way over, then it should be at 100% progress. And so by getting this dot progress, I can get it. But how, based off of what we learned previously in lecture, how would I be able to get seek bar hue in my Kotlin file? Does anybody know? How would I be able to get the seek bar in my Kotlin file? So the seek bar is something that should exist in a layout, right? Yeah. Use the ID, exactly. So the seek bar is going to be in my XML layout file, and I'm going to want to pull it into my Kotlin using find view by ID, and whatever I had given it an ID, maybe I gave it Q bar or something like that. And now I have access to it in my Kotlin file, and I can do things like get its progress programmatically, and then convert it to a float and put it in the first position of the array. Does that make sense? Yeah. Yeah. The last part about having to get the what? Yeah. So this seek bar is going to be a layout element, and this layout element, like all other layout elements and all other views, exists within the XML file under res layouts. This is where I define all of my layouts, my app layouts, how I structure like the user interface. So this is where I'm creating this seek bar, and then to change things about the seek bar programmatically, i.e. in the Kotlin, like the actual Kotlin activity class, right? I'm going to have to get it by its ID, find view by ID, and then I can do things with it once I have it within that file. Does that make sense? Are you able to follow all of that? Okay, and if any of this is confusing, don't worry, the demo should hopefully clarify this process. So any other questions before we move on to the demo? Okay, cool.
Hopefully it's finished building at this point. I mean, uh-oh. Mm-mm.
Is this the right one?
It's both of them. All right, give us a sec. We are experiencing technical difficulties.
You want to try yours? I could also demo the solution.
Hmm?
You could also demo the solution.
Just be warned, my computer is slower than a couch potato.
Wait, why is it doing that? We'll talk about homework two. So in the meantime, I'll go ahead and go over what homework 2 is this week. So let me go ahead and pull it up. So, all right, let me refresh this. So, okay, for homework 2, what you're going to be doing is you're going to create an app where we can use RGB to construct an element, or to construct a color. So we're going to have a seek bar representing its red value, its green value, and its blue value. And this has a specific lower bound and upper bound. So if you're familiar with the Rgb color space, it should be each value as a minimum of 0 and a maximum of 255. So the idea here is that we want the seek bar to react to what the color is. So if I brought the red all the way up, I can watch the color of this square get more and more red. So it should be changing in real time. And the other thing is take notice of the fact that we have a text view to the left of each of the seek bars, and that the seek bar matches the color it represents. And one of the requirements we're going to have to do this week is we're going to have to use a constraint layout. So we'd mentioned that there are different types of layouts that you can use, and the constraint layout is sort of industry standard, and so we want to push you guys towards using the constraint layout in this case. Another important thing is making sure that your text views are aligned properly. This is an important detail, and the other thing is we're going to want this app to be able to be in landscape or portrait orientation. So it should be, if I had flipped the phone sideways, I should be able to actively see that it had changed to that. So this, for a lot of people, can be confusing to demo if you were using an emulator. Just know that when you're using the emulator, there is a button that has, it's like an icon of the phone going this way and like a little arrow. That's what you use to actually orient the phone in the opposite orientation. Okay, any questions about what the homework is right now? I know we went a little out of order, but any questions on homework 2? And we'll be due in a week from now, or Sunday midnight, I guess.
I guess the maximum value of RGB is 250.
256? I thought 255 was the max. Oh, okay. Oh, yeah. I guess it's an upper bound, but I don't know. I guess when I learned it, it was 255.
Because the maximum is FF.
Wait.
Yeah, no, it's like hex colors. So like, when you represent it in hex, like the maximum value it can take is like FF, which corresponds to 255, I believe, because it's not quite 256. It's just one word.
Okay.
Okay. I might have to re-record this later.
Okay, we're going to now transition to the demo.
All right. Let's see. Fair warning, my computer is really slow. So if you see my mouse not moving, it's because it physically cannot move. All right. So yeah. Can you wait? It's okay. I'll just re-record this later. It's fine. Yeah. Anyways, can everyone see the screen? All right, cool. So, anyways, yeah. And so first, just brief overview of constraint layout. You see here I have a constraint layout in my activity main, and it's the parent of this text view here, which is centered. And now what you can see that in a constraint layout, I can add constraints to the child of an element. So in this case, the constraint layout is the parent of this text view, and basically the parent of whatever type of view is just like the element that's like immediately containing it in the XML. And for a visual representation of this, you can see when I click on the component tree, you can see that the text view is like directly nested inside constraint layout. That's what it means for something to be a child of, for the text view to be a child of. And as for constraining this text view to be centered, you can do that by adding constraints to it. So in this case, you can add constraints by adding using this layout constraint feature. And linear layouts, yes or no? Okay, let's see. How about we do seek bars first, because that's going to show up on your homework. So to create a seek bar in the XML, we just have Android Studio autocomplete things for us. And let's see, rep content. All right, and Android Studio is complaining because we have no constraints. So one way you can add constraints is by actually just like dragging the constraints. And you can see my Android Studio is not responding because my computer is a brick. That is okay. There's a reason we usually run demos not on my computer. But yeah, yes, you can constrain this seek bar. So it's now centered, and in main activity, I can go grab this seek bar programmatically. Let's see, I'm just going to create a seek bar variable to hold this seek bar. And I am going to use find view by ID to grab this, as Adam mentioned in lecture. And to do that, I first need to add an ID to my seek bar, which I have not yet. So I shall first do that, Android ID. And I will give it the very creative ID of seek bar. Again, r.id.seekbar. That allows me to grab it. And now I would like to actually do things with this seek bar. So, for example, maybe I want to know like what happens when, I like drag it. But first, in order to, just want to mention for homework is that you can set the maximum value of the seek bar to like something other than its default value. So I can set it to example for 500, so that like the max you can drag it to is 500. So I'll just do that first. And I can say, well, I want to do something when the seek bar is dragged. So I will set an on seek bar change listener to do something when someone drags the seek bar. And this is not something you have to memorize. Okay, but the one method that you're gonna mostly be doing your work in is on progress change. This method is called whenever someone like drags your seek bar and the progress value of the seek bar is changed. So for example, I can create another text view here. Aha, I have a text view there. How nice. And I can set this text view to be updated with the progress of the seek bar question. Okay, sounds good. Good question. So latent var, first of all, var means I can change the value of it, unlike val. And latent means I don't initialize this variable when I first declare it. So for example, you can say, val, tiger equals tiger, for instance. And I give it a value immediately. However, sometimes for views, you want to init them later in onCreate. And, if you don't initialize values with a value directly here, Android Studio will complain. That's why I say I'm going to initialize these later in onCreate. Does that make sense? Good question. And yeah, and I will also do text view equals find view by ID, r.id top text view, and when the progress is changed, I will try to set the text of the text view to change along with the progress of the seek bar. So I can say, not seek bar, text view dot text equals, let's see, I believe P1 is the progress. String. And I will convert this into a string. And now hopefully this text view will not actually show up because it is probably right behind. Yes, it is probably right behind the other seek bar. Very sad. Okay. Okay, I will instead have this text view's top constraint to the bottom. Okay. All right, okay, so my original plan was to constrain it to the bottom of the seek bar. That is not going to happen right now because my computer is taking another break. Yes.
I just want to mention, so did you guys see how when Shirley had tried to set the on-seek bar change listener that it automatically made her implement the other methods, like on seek start and everything. So you can sort of think of this as seek bars having an interface. So you guys are familiar with interfaces, and so if something implements an interface, then that means you have to implement its methods. So you can't have a seek bar without having these three methods because they define the behavior of every seek bar. Yeah. Sorry, one more time.
Okay, yeah, so what happened is I hovered over the red squiggly that appeared over object, and when you hover over it, there's like a link that you can click on to quote unquote implement members. And implement members basically means like implement the methods that this interface is supposed to have. And then at that point, it will automatically just populate those methods for you. And that's how that's how that was auto-generated.
And these methods automatically had the arguments passed in and everything, where you knew one of them represented its progress. I think it was P1.
Yeah.
Yeah.
You can definitely rename these variables if you want them to be better named. They are not very well named by default.
Yeah. What does fun do? Fun is means function.
Okay, this is a very, very, very short seek bar because I did not get it to match the width of its parent. But you can sort of kind of see the the very minimal changes that are needed to make this progress go from 0 to 500. You should, if you want to make this seek bar wider, you can change its, in this case, I would be changing its layout width. Instead of wrap content, I would probably change it to something like match parent in order to make it match its parent, which I will do at some point.
Yeah, because the parent element of the seek bar is the constraint layout, which right now is covering the entire screen, the whole. So when you say match parent, you're saying match the thing it's within. So I could have a linear layout inside of a frame layout, and then the seek bar inside of that frame layout. If the seek bar says match parent, it's matching whatever is directly above it, the frame layout. Does that make sense? Why would you make it what? Like to align them next to each other? So like so this is done with the constraints, right? So you can constrain something to the bottom of to the right of some other element.
All right. One quick thing I'm going to show you is this view element. You should probably not hard code these, but use dimensions instead. But I will show you. I will show that possibly later because I want to cover some other stuff first. But yeah, this is nice if you want to just like have something have a color. So I can just set this background to be like teal, for example. And you can just like use that when you want a color of some sort and don't want like any other like functionality, like it being a seek bar or whatever. Let's see. Yeah. One other thing is, Adam was mentioning earlier how you can generate other XML files for like landscape mode, and how you do that is you click on like this button here, and you create the landscape variation. And when that happens, it'll like just pop up here, still inside layout, and you'll be able to see basically how the app looks when it's in landscape, and when you change this, the landscape behavior of your phone will change as well. I'm gonna rerun this real quick just to show you guys how this works. And also, there are some like tricky things that you might run into when changing orientation on the Android emulator. But anyways, to rotate the phone, you can click on like this button and that button. However, your phone orientation will likely not change unless you have this toggled on. So make sure that if your phone orientation on your emulator is not changing, make sure that this little icon is selected, or else your phone orientation will not change. And yeah. Okay, let's see. I have 1 minute left of actual lecture, so I think I will show linear layouts. So linear layouts are another type of layout. They're kind of sort of, I guess, in the family of similar to constraint layouts, except instead of constraining their children, linear layouts line up their children linearly, either horizontally or vertically. So let's see, if I just get this linear layout to not freeze on me, I can set its width and its height, and I can also give it an orientation. So let's see, just like match parent.
So the way to think about linear layouts is basically that each view within the linear layout is itself a rectangle. So I could have the rectangles go this way, this way, this way, or I could stack them this way, this way, this way. Yeah. No, right. Constraint. I don't think we're gonna.
Don't use a linear layout in place of a constraint layout.
Yeah.
As a child.
Oh, okay.
Yeah, it's fine if you like use it as like a child of a constraint layout. Just don't have the biggest like the overall parent be linear layout. Yeah. Yeah. So in this case, you can just like see the linear layout just like lining up its children vertically because I have the orientation set to vertical. Otherwise, horizontally, you can see it just like changes the orientation of its children. So that's useful if you ever want anything to show up in a line, I guess. Yeah. Yeah, that's like the most important part.
Okay, cool. All right, everyone. That's going to be it for today. We're going to stick around afterwards if you want to get some help getting started on homework 2. But otherwise, thank you all for coming. Hope to see you guys next week.